This topic is one that's becoming really near and dear to my heart. Various features of PyCharm are to take something in Python that might be a little complex, a little bit intimidating, and make it a lot more accessible by putting a visual face on it. Whether it's visual debugging or visual profiling or visual test running, etc. Several of these Python skills that you know you need to learn but don't. And I'm always surprised at how many people are still doing debugging using, for example, print statements. This webinar is going to start from that point, from the I'm not doing debugging, I know I should, and then we'll get into some intermediate topics, and then depending on time, we'll close out with some more complex extra credit kind of things. For this webinar, I'm going to leave my table of contents in Markdown visible at all times, partially as a cheat for me to help cue myself, but also for you to see what I'm talking about and see what I'm going to go through next. I'm going to start with non-visual debugging using print statements and the command line PDB. And then we'll go and solve a problem using the visual debugger and then show how to speed things up. We'll go into breakpoints, different flavors of breakpoints, and then we'll go through stepping through code, the various different kinds of ways, as well as some pretty cool tricks for productive stepping through code. We'll introduce the concept of stack frames, which throws people for a loop, and then show how it can be useful during a real-world debugging session. We're going to set some watches, which is also another productivity increase. Then we're going to get into some things that you may not use or may not even know about. How can I debug something that is not launched by PyCharm by attaching to processes? The visual testing that I alluded to, how can I do visual debugging as part of test-driven development? For those that are switching to Python 3.5 or higher and using type hinting, PyCharm can help you on that, and we'll show that. Boy, one of the killer features for PyCharm professional debugging is setting a breakpoint in the middle of a Django or Flask template or pyramid. We'll show that, and then we'll get into the integration of debugging and data frames. As I have done recently, I will show all this in the context of writing a 2D game using the arcade library, which is a wrapper around Piglet. Nice, fun, lightweight, simple system for writing simple games. Onward, let's get on to old-fashioned debugging. So if I run this game right now, I'm going to run it. It's going to pop up a window. I move my little character around. And in arcade, everything is from 0, 0, X and Y, but where is the 0, 0? Is it up here? Is it down here? Let's do some debugging techniques for how I might find the answer to that. So for example, I might put in a print statement whenever the mouse moves. And so now when I run this, I'm getting down in the output and I see, okay, well, it's probably down here in the bottom. It's not up here in the top. Well, that's one way to do debugging, is to use print statements and then start diagnosing problems either in your code or in the Python library code. And then you got these print statements sprinkled all over the place and you can't really interact. You have to rerun your code to do it again. That's when people usually take the step up to Python's debugger, PDB. And they use a set trace to stop execution at this point and let them poke around. So now again, I run the game using PyCharm's run tool window, and I can move around, and I'm already stopped in that breakpoint, and I can print the X position, I can print the Y position. That's because in this scope where the breakpoint was set, I've got an X and a Y. Relatively straightforward. The normal way for the last 40 4 years of Python to do debugging. But for many people, this is intimidating. You've got this language that you have to learn for moving things around. And then if you want to display where you are, you have to run another command to see what position you're at. And then as you dive into code, you kind of get lost with all of these things. Wouldn't it be nice if there was a visual feature on this? So I'm going to stop the execution of this game. And instead of having
stop you for one quick second.
Sure.
We already have 2 people asking here, is this code available somewhere?
I have it in a repository. I questioned whether it would be valuable to share this because it's very little writing of code, but you've already answered that. 2 people have asked. And so, Ernst, how about we, along with the announcement for the recording, we will announce the GitHub repo.
Sounds good. We'll put it on the blog.
All right, great. And as an FYI, the markdown document that's driving all of this will be in the repo as well. So we just saw old-fashioned debugging. How can we run under PyCharm's visual debugging? And then how can we set a breakpoint and accomplish the same task? So I'm going to delete this line, and I'm going to run this under the debugger without a breakpoint just to show that you can run your code without debugging under the debugger if you want to. So this time I'm going to click the debug game instead of the run game. And it's going to run in a window very similar to the run tool window, but it's the debug tool window. You see that it's highlighted here. And I can play my game. Whee! Same as always. Looks very similar, except I'm running it under PyCharm's debugger instead of running it under Python directly. When I do that, if I'm on Mac OS or I'm on Linux, I see this odd thing in the console window. What does that mean? Well, I'll take a little digression because it's so super cool. Over the course of the last 2 years, the PyCharm team has really worked hard on making debugging a first-class experience from a performance perspective. One of the first things we did was we share the debugger backend, PyDev, with the Eclipse PyDev project. And in fact, the Eclipse PyDev maintainer is the one who is the maintainer of PyDev. And we funded him to do some speed ups on the debugger and fix some bottlenecks. And then most importantly, have a Cython option of the debugger backend, which dramatically speeds up the debugger, like 4 times faster. On Windows, we ship the compiled Cython speedups. Currently on Mac OS, we do not, nor on Linux, but we make it dead simple to compile it. So if I just click here, it will go off, it'll run some compilation stuff in the background. You won't have to think about the Cython compilation process. And then for this version of Python, wherever it's used in any of your projects, in any of your virtual environments, it will have those Cython speedups for the PyDev backend. So I'll let that run a little bit longer. We also did some other speedups after the Cython speedup. If you're using Python 3.6, we take advantage of new APIs that are available in Python 3.6 to give a rather shocking speed up. Thank you to Elizaveta for that. And in the latest version of PyCharm, we're getting close to the experience of debugging running at the same performance level as running, in which case maybe you just run under the debugger all the time so you don't have to do an extra step to do a breakpoint. Now when I rerun this, I don't see that message, everything pops up and it feels just as fast as if I ran it not using the debugger. I move everything around, we're all good. Let's go back to solving that same task, the same problem about where is my 0, 0. Now instead of having to type in some import PDB, pdb.setTrace, sprinkle around all over the place and navigate it using a clumsy UI, I can do visual debugging. I can set a breakpoint on that line I can run it under the debugger, and execution will stop at that point. Execution will stop at that point, and I get an indication of where I am in the code. I get all the local variables in all the various scopes, and I get a whole bunch of coolness that we will see during the rest of this webinar. So I will stop at this point to see, do we have any questions about the speed ups or about visual debugging with a breakpoint?
We don't have questions about either of those topics, but we do have two other questions.
All right.
The first one is by Rotimi Dubi. My apologies if I mispronounced that. Where can the arcade be imported? Is it part of the Python SDK?
It is a very simple installation. I have it. I'll open my requirements file. Oop, that's simple. Oh, here it is. I have it as arcade in my requirements file, and so then I can pip install it. You can also go to your interpreter and use PyCharm's visual approach to installing packages. And then you can just install arcade. It is in PyPI, so it's a easy install.
Okay, thank you very much. The second question, what's Cython? Why is it called Cython?
Cython is a project that's been around in Python for a while. I would say at least a decade. And it is a way to convert bottlenecks in Python into C code that is very easily integrated into your Python code. And what you're doing is performing at the speed of C instead of at the speed of Python.
All right, thank you so much. Those are all the questions.
Right, great. All right, I will continue on. Next, let's solve a particular problem. So if you see here, this is the score that I'm outputting on the screen. And I'll run this again, and we see that here's my game. And I see that score is written on the screen 0, 0. But any of you longtime Python people will know this is the ancient cave drawing version of string formatting in Python. We sure would like to use that cool new syntax that Python 3.6 introduced for formatted strings. Well, sure, PyCharm can help you and choose the quick fix. Look how great PyCharm is. Let's say I didn't know that was there. I don't really know the syntax, and I have some local scope, self.score. At that point, how about I set a breakpoint and interactively fiddle around until I get the correct syntax for that. So I'm going to set a breakpoint right here, and I'm going to rerun my code, and I'm actually going to rerun it. If I mouse over this, I see that I can rerun it with Command R. If I come up here, I can also rerun it with Command D, with Control D. So I'm going to do Control D to rerun the debugger from the keyboard. I'm stopping at this point, and I want to poke around until I solve this problem. What is it that the F string syntax? I don't quite know. Let's say there's an F, and then there's this single quote string thing. Then after that, I might want to say something directly outputted, a literal score, and then I think it's a curly brace. And then I think I've got access to my scope here, so I can say something like self.score. And then there's this syntax where I do a colon and a 0 to D, and then I close my bracket. I wonder if that's it. Evaluate, yes, yay, that's it. My score is 0, I've got the expression. So I'm interactively exploring using the debugger the programming question that I have. Well, there's another way to do it if you don't want to use that evaluate expression. We're stopped in the debugger window down here, the debugger tool window. And I have access to self.score and all my variables, but I can also go to the console tab and I can turn on the console prompt, and let me mouse over that again. I'll make my window a little bit bigger so that that appears. As I mouse over it, show Python prompt, that's in the debugger console, I'm getting a prompt. And what's in scope here? Well, I've got a self, and I've got a self.score. And maybe I could do that same thing, f score, and then self.score : 02 D. And that works correctly. And I can sit and poke around and do all kinds of things. The nice reason for doing it with the debugger is, sure, I could open the Python console and poke around. And that gives me access to the code, but not the state. Maybe I want access to the state during execution at that line. Then I figure out my answer, and then I, take this, cut, and paste it up here, and I'm like, yay, I figured that out. Yay for me. I'm using PyCharm's terminal completion and all that kind of stuff here. IPython is much better. Wouldn't it be great if we could use IPython? I wonder how hard that could be. So I will go ahead and stop this. Oop, clicked one time too many. All you have to do to get access to IPython in all of your prompts in your terminal, Python console, debugger console, etc., is just install it. So I'm going to go back to that project interpreter I was just on. I'm going to install IPython, install package, and it's going to go off, get the latest version of IPython. That was just released. I hope that doesn't break anything. And then when I come back and do the exact same thing again, I'm going to rerun this game, stop at that breakpoint, go to the console, and when I show the Python prompt, you'll see that it looks different because I'm now in the magical world of IPython. That is not unique to the debugger's console. Also the Python console. No, sorry, I already had that one open. The Python console is now using IPython as well. So I'm going to stop at this point. Do we have any questions about interactive use of the debugger?
Yes, somebody asked, is BPython also supported?
I will give that to your team. I don't know. I don't think it is. I'm 95% sure it isn't. So I will say it isn't until someone says that it is supported.
It is not. I just got confirmation from the team. Sorry
Hooray for
about that.
me, you got something right. All right.
And now somebody just asked, could you please say again how to install Cython on Ubuntu for the debugger?
You don't need to install Cython itself. It's not like you need that package installed. I believe we ship with a Cython. It's just you need to click that link to do the compilation process.
Yeah, I'm 99% sure that that's correct. And what is IPython? Somebody asks.
IPython is a Python package. Let me go to Python. Originally a dual-headed thing that included IPython Notebook, now Jupyter Notebook. They split the interactive console-y thing from the web-based notebook thing, and now IPython is used to mean the console thing. So if I go back to let me just search for it. It's a package from the Python community that allows you, let's say, a rich toolkit for using Python interactively. Whole bunches of features, configuration files to govern it, a different syntax to go backwards and forwards for your previous commands, rerun previous commands. Here are a bunch of the features for it.
All right, great. Thank you so much.
All right, onward. Okay, breakpoints. We already set a breakpoint. Let's take a look a little bit more in depth at these breakpoint things, again, to solve a problem. In Arcade, when I'm writing an arcade game using the class syntax, I'll make this a little bit. I write a game that subclasses from the arcade window, and I fill in these magic methods, and they do things. And the animate magic method is passed a parameter called delta time, which you can choose to use or not use in your method, which governs the redrawing of the recalculation of things that need to be redrawn. Well, what is this delta time? We can get the explanation if we needed to by going to the superclasses slot for it. And it tells us the time interval since the last time the function was called. Okay, that sounds pretty good, but let's actually explore this for real. I'm going to set a breakpoint here. And now when I rerun my game using Control-D, I'm going to stop at that point. I'm going to observe this value, and it's 0.05. So it was 0.05 seconds since the last time the animate function was called. Well, I've been talking for a while. Let's go and continue processing past this breakpoint, past this line of execution by saying resume program. When I resume program, it's going to go hit that breakpoint again. Why? Because arcade is calling animate frequently. In fact, it's calling it every delta time seconds. And since I was talking for a long time, it was 26 seconds since the last time it was called because we suspended execution. If we go a little faster, we see that it's called more frequently than that. And if I didn't have the breakpoint, it would be called every 1/80th of a second. So in this case, I used a breakpoint to stop execution at this line, take a look at a variable in that scope. I could, if I wanted to, take a look at some other variables. For example, what's the current score? The current score is 0. What variables are available on self because what attributes are available on this instance because I subclassed from window? Well, I got some stuff that came from the superclass. I also have a sprite list and other things. So the breakpoint that we set stopped execution in the animate function, gave me a friendly view of the variables that were in scope at that point, and allowed me to resume execution. Let's go solve, instead of just poking around to learn, let's instead, oh, actually, something I wanted to show, resume, and now it runs, and it doesn't need my help for anything. And I can move around, etc. If I wanted to set that breakpoint again, do I have to restart my program in order for the breakpoint to be effective? The answer is no, I don't. That's something I see a mistake quite frequently. Breakpoints are dynamic. They're injected and removed at runtime during the execution of your code. That's part of the magic of them. So now I can remove that breakpoint and continue. All right, let me stop both of these since I'm going to solve that problem right now. I accidentally get to the point where I've got a couple of these running. All right, I'm going to go to my run configuration, and I'm going to check this box that says forever and ever, never run it more than once, so I don't make that mistake. Now let's imagine that I have a little typo. My character, the Dora the Explorer, I've got a typo in the PNG file name, and I run my code. I can run it under the debugger because the debugger is really fast. I'll do Control-D, I'll run it, and I'll stop at a breakpoint. Now, note that I didn't create that breakpoint. And in fact, it's not even in my file. It's in a file that belongs to Pillow, actually, a library that I installed. Why do I have that breakpoint here? Well, this is a pretty cool feature of PyCharm's visual debugging. If I go to the tool window and inspect all the breakpoints that I have set anywhere, By default, PyCharm has a breakpoint that will stop on any Python exception that doesn't get handled by your application or the framework that's calling it. I can turn that off if I don't like that support. I can also go to the UI and have a very rich UI for managing information about every breakpoint that is set. For example, this is a great one. Maybe I want PyCharm, the debugger, to stop whenever there's an error, but only when there's an error in my code, not when there's an error in the libraries that I use, because you don't want to be stomping all the time. It'll get really annoying. So that's where that breakpoint feature came from. And then I take a look at this and I see, what is it doing? Why can't it open the file name? I gave it the, oh, yeah, look, I gave it the wrong file name. And if I wanted to see, how did I get to here? We'll talk about this a little bit later. This is a very good example of using this feature. On the left-hand side is a little window called frames. In Python, when you execute, you go into frames of execution. When you call a function, you go from one frame into a new frame, but Python doesn't throw away the previous frame. As you go down the layers of the onions, Python keeps all of those layers of the onions and all the state that was there. And so, for example, I can go and look to see that is the line that called this line, that called this line, that called this line, that raised the error. And in my code, the frame that called the underlying library code, I see the state of the stack frame and all the variables at that point of execution. And as I go through each frame, I see all the local data for that part of the code as I keep going down. So I'll resume execution, and now I know where my error is. I can go and fix it and rerun my application. Oh, good news, Dora's back. All right, I will stop at that point. That's a treatment of breakpoints and the UI for configuring settings on them, as well as the default any exception breakpoint. All right, so you got anything?
I do. When you have the animate function, a couple of people were wondering, how do you know it's 1/80th of a second?
It's in the documentation for Arcade. That would be an interesting one to go explore around a little bit in the debugger and step through all these things and find out what is it that calls animate, how did I get there, and what set the default time. I'm a contributor to the Arcade library, and so I know that you can pass an argument that affects the rate at which animate is called.
Okay.
But that's not the topic of this discussion. It's a topic about Arcade.
All right. Would you know if there are any differences between visual debugging of Python 2 and Python 3?
Python 3.5 or higher is a lot faster if you're using 2017.1. And if Elizaveta is on the questions, maybe she can answer. I believe she's got more planned for other things that can be done on that. But primarily the behavior is exactly the same. It's just a performance difference.
All right. Thank you very much.
All right, cool. Now, Dora's moving around, but the purpose of this game is for Dora to pick up some coins. We want to put 50 coins on the board at startup, and we want to put them at random positions. So we go ahead and start typing our code. And our code for this in Arcade is I'm going to make a coin list that's a Arcade sprite list. And I'm going to do a normal in range to 50. And I'm going to make a new coin using the Arcade sprite class, and it takes an argument of the file to use for the coin and a scaling factor to make the coins bigger or smaller. And then I need to put the initial position of the center of this sprite. It's X and Y position. So I'm going to set the center first. I want it to be kind of random. So I'm going to use Python's random library. I'm going to ask PyCharm to import it for me from random. I'm going to use random in the range of the width of the game. And I set my width here to be 600. But I don't really trust this. Is it really giving me a good distribution of this? I'd like to go and run the game a little bit and have it create some of these 50 coins and take a look at that position. Let me go ahead and duplicate this to put the Y in as well. So I'm going to set a breakpoint here. I'm going to run my game. And since this is in the constructor, it's going to stop me immediately before the game ever appears. And I can see that I've got a coin instance created. And that coin instance is going to have a lot of data in it, but it's going to have a center X that is 191. Well, let's take a look at the next one. How can we step through our code and take a look at these X's and Y's for the coins for each of these 50? We're in a loop. We want to step through our code. So I'm going to use the step over function. Stepping in debugging is a well-known concept. In Python debugging, it's a well-known concept. In PyCharm visual debugging, it's really easy because we have a variety of stepping features with a pointy clicky button. You don't have to memorize anything confusing. So I'm going to step over. I'm going to go back into my loop. And I'm going to take a look at this center X is at 0 right now. No, I'm sorry, is at 155. What's the next one going to be? The next one's 357. What's the next one going to be? 382. So they do seem to be somewhat distributed. Now, as I'm going through this, I might decide that I want to know a little bit more about this sprite function. What is the 0.2 that it's doing? What does that mean? What is the effect? I want to step into the execution of this code, the creation of this class. And we have step into is a way to, instead of going to the next line, go into the code that's being executed at this point. So I'm going to step into that. And I see that I'm in the constructor for arcades sprite class. And I'm on the first line in there. And I can do my same step over, go through all of this, see how it's all being constructed, etc. And then when I'm done, I want to step out and go back to the code that I was on. And then I can resume my step over. Oh, I learned a lot about that. That's great. So I do step over, step into, step out, step into, step into. Oh, wait, I got taken into the Python standard libraries random module. Well, I don't need to debug random. Everyone knows what it's done. It's been around forever. That was a mistake. That kind of slows down my workflow. I got stuck going out, looking at code I wasn't interested in, and now I got to step back out. Wouldn't it be great if I could just choose to step over and into my own code instead of, so I've got step over and I've got step into my code lets me go into functions or classes or modules that are in my package. But here, instead of stepping into the sprite code, it's going to skip it. And instead of stepping into Python's random module, it's going to skip it. And so that's a pretty handy feature. And it's letting me do all the exploring that I wanted to do. Yes, I am getting random positions. I was able to step over, step into, do all my stepping, excuse me, to learn about that programming question that I had. We have other things such as run to cursor, where I could put my cursor here and run to that point. etc. Next, I'm going to do my collision code. So I'm going to take out that breakpoint. I'm going to resume. Here's my game. Yay, I can still move around. Oh, actually, no, I don't have my coins. Got to put in the last line. I need to take this coin and append it to my all sprites. Something's going wrong with my execution. Execute this. And I got a bunch of coins on the screen. All right, next, I want to do collision. Again, I can run this. I'm moving Dora around. She's collecting coins. Nothing's happening. Arcade has a collision detection system that we can put in our animate function. And so I'm going to tap into that. Oh my God, this is so easy. I'm going to keep a list of anything that I collide with using Arcade's check for collision with list. And my list of things is I've got a player sprite. Is it colliding with anything in the coin list? If there is anything in there, I want to process each one of those coins that I collided with. And I want to kill it, kill the coin. And I want to increase my score by 1. Now when I run the game, again, I'm running it under the debugger because the debugger's fast now. It's running around and look, my score is going up. I'm colliding with coins, etc. Now, I want to know a little bit more about how this actually works. So I want to step through all the coins in the hit list and understand a little bit more about the score going up, and watch the score going up to make sure that the score is going up the amount that I think it should. So I'm going to set a breakpoint here. I'm going to run again under the debugger. My game pops up. Let's see. And as I move around, I'm not triggering the breakpoint, trigger the breakpoint. How big is my hit list? My hit list has 1 item in it. And my score is still, let's see. My score is now incremented by 1. And I can continue. I want to clear that breakpoint for the next thing. Instead of going and clicking on it, I'm going to go here and delete that breakpoint. All right, that is all that I have for stepping. I'll stop here and answer any questions.
Well, we have some good questions for you about shortcuts. First is, what is the shortcut to make auto import?
Alt-Enter on the Mac. So, for example, if I want to say get current working directory, which we will do later, that's from the Python's OS library. I said Alt-Enter to show intention actions, and down there I've got the presentation assistant installed for my webinar that will show you the keystrokes that I'm doing on my keyboard. So I'm going to hit Alt-Enter right now. Alt-Enter on Windows and Linux brings up the show intention actions. And one of the intentions I can do at this point is import the name. Does that answer the question?
You did. And there's another question here about the command for duplicating keys. Or duplicating lines, sorry.
Duplicating lines, yeah. So let's say I wanted to duplicate this line that I'm on. I'll just let the presentation assistant answer it for me. It's Command D.
And
which also triggers the duplicate line action. If I don't want to remember all these key commands, just remember on Mac, Command-Shift-A to search for actions. And I say duplicate. There it is. I can just hit there.
Great. Then we have another question, how to step out from the for loop.
That is not a debugger question. That is well, if you want to step out of it without executing any of it, then you have to put in a break or whatever in Python. If you want to stop stepping and go to a line that's after it, for example, return, and I was on a breakpoint here, then I could put my cursor there and use run to cursor.
All right, thank you very much.
All right, good. These are all very good questions. Thanks, Ernst.
You're welcome.
One of the things that we just saw in the breakpoints and looking at variables was sometimes there's data down in a list, and whenever I stop, I have to go down to it and maybe expand 3 things to get down to it. That's kind of inconvenient. So let's do the same thing to see if the coins are actually decreasing. Let's do the same thing. Set a breakpoint here. And when I run the debugger, oh, I was still running. Let's see. Oh, it's in a zombie state. All right. So my game's running. I collide with something. I've stopped at the debugger. What's my score? Well, crap. I've got to expand that, scroll way down, maybe use the speed search, or I can set what's called a watch expression. Watch expression can be as simple as a variable, and it tells me my score. And as I step through, it reevaluates that and shows me the answer, even shows me the type information for that. Very handy way to, instead of having to look at the big pile of state at the point that you're on in the debugger, focus on a small pile of state, a watch expression. These can be edited directly, they can be deleted. Well, that's one good watch expression. I'd also like to find out if my coins are actually being reduced. It says kill. What does kill do? I don't want to go back over and watch the output. I want to stay in my IDE. Well, the coins are being added to a list called coin list. What if I added an expression instead of just a variable? I want to do a calculation. Those are stored in the coin list, which is in my autocomplete, and I want the length of that. At the moment, it's 49. As I continue through this, it goes down. As I leave the scope, I get an error because score is not an attribute of the scope that I was on. All right, so I'm going to continue this back to my game. I'm going to move around, trigger that thing again. I'm going to step through my code. I'm going to watch the score go up. And the number of coins go down. Because we're already at 47, I'm not going to go into further depth on watch expressions. I will say watch expressions are the point at which you move from being a beginner debugger to a more advanced debugger. You're using the tools of visual debugging to make your life easier for you and your coding more productive. Ernst, got anything?
I have nothing.
All right. I'm going to use the question of what coin am I on when I am adjusting the position to introduce a little bit about stack frames. So for example, here when I'm setting the center X, I'm doing it on 50 coins. Well, how does the center X actually work? I'm going to set a breakpoint here, and I'm going to run under the debugger again. And it's going to, let's see, it's going to stop at that point. I'm going to step into that code. Well, let's see, I'm going to step into that code, which takes me into random. I'm going to step out, but I'm going to step in again because center X is actually a property in Arcade. It's dynamic. Center X is a property with a getter and a setter, and here I am in the setter. So stepping through code revealed something that was not obvious just by looking at the Python. This is a setter. Well, what coin am I actually on? If I go back in my scope, I see that I is 0. So I'm on the very first coin. I can move back in the frames to get to the point that I called this line and see what was the state at that point. Again, in the interest of speeding up, I will stop at that point. One thing to add, as I move through, my watch expressions start failing because they are pointing at attributes and functions and things that are not available in that scope. Ernst, got anything for me?
Sure. Where do I go to get more information about watch expressions?
The PyCharm help actually has good information on this. So if I say PyCharm help watch expressions, Google will take me to the latest version of PyCharm, which is good. Make sure you don't go to an earlier version. If I went to this, the help system will actually do a good job of telling me that I'm out of date. Let's see my window over here. No. Oh, because this page has been refactored. That's why there isn't a newer version of this page. So everything that I want to know about what is the concept of watches, this is the concept. How do I create them? How do I edit them? How do I delete them? Next question.
These not equal and arrow operators, what are they? Is it Python 3.6 syntax?
Let's see if I can, I'm guessing that they mean this.
I think the same thing.
This looks weird because this is actually a new font supported by PyCharm called Veracode. I think we bundle it now. And this is a type of font that supports something called ligatures. And ligatures are a way to take things that look wrong when typed in, say, ASCII, but are programming things, and make them, for example, equal now turns into they're all together rather than being split. And various other things such as not equal, etc., are given a different font, even though under the hood it's still the equal key plus the equal key. What's next?
That's all for now. Thank you so much.
All right. I'm going to go faster through these because we're getting close, and I think we really want to see debugging in Django and Flask. If you're into TDD, then debugging is great for TDD because usually you're stuck just printing things when you're trying to figure out what's at a certain point in my test. So for example, I want to go to my tests. I can run my tests, my unit tests, and they fail for several reasons. Is stopped doesn't exist. And I'm thinking to myself, man, I did that. I did support for the is stopped feature where the score, it doesn't show until the cursor stops. I'm going to prove it. I'm going to set a breakpoint right here. I'm going to rerun my tests. Oh, I'm running under the debugger. I'm going to run my tests under the debugger. I wasn't running them under the debugger previously. And it's going to stop at this point. And I'm going to step into that. I'm in the constructor for my game, and I'm looking at it. See, I've got the score. Oh, no, I haven't put the is stopped on here yet. Oh, I need to go do that. So I've got the benefit of debugging during TDD during test-driven development, and I can help solve a problem about why my test is failing by using debugging to step through my code and the state in my code and interactively poke at things until I fix my test. Got any questions for that segment? We're going faster, so I doubt you do.
I don't.
All right, great. Okay, let's see. I've been running my game, I've been launching it under PyCharm, and that's great when you can launch things from Python, but sometimes there are things where Python might be embedded into something, or Kivy or something where it's got its own custom launcher and it's not easy to launch under PyCharm. What if I ran my arcade game? I'm going to close that. From a terminal. I'm doing the terminal in PyCharm. It could be the terminal with my operating system. If I ran my game, not quote unquote under the debugger, and it's moving around and all that stuff, how can I attach to this Python process from my IDE and do all that debugging stuff that I was just talking about? Well, fortunately, the run menu has this thing called attach to the local process. It gives me a handy listing of all Python things running on my computer. I select the one that I want. I want it to attach to game.py. It's doing some crazy stuff at a very, very low level to go and inject itself into a running process. And so now when I kill a coin, I can set a breakpoint, go back to my game, and as if by magic, because this really is magic, I'm debugging a Python process that is running outside of PyCharm. All right, I'll stop at that point. Got anything?
I don't.
Okay. Let's see, I'll go back to my game, stop my game, make sure the terminal, yep, it's good. Okay, I'm using Python 3.6. Python 3.5 and 3.6 have type hinting, which is really cool. I can go and put things, for example, I can say that this is an int, so that everything is completely obvious. I can put that this is an int. Boy, this is a drag, going around and putting all this information on here constantly. PyCharm excels at being your janitor and doing your janitorial work for you. Does PyCharm have a mop to clean up this mess? Well, it actually does. I can run something under the debugger, run my game under the debugger, go and, oh, nope, that's the wrong process. I can run my game under the debugger, go do all my stuff, much, Dora's happy, Dora's getting rich. Finish my game, and then come up to here, and we talked about the quick intention stuff, Alt-Enter, annotate types, and it, while the code was being executed under the debugger, it recorded information about this under init getting called, about the arguments being called, about the type of those arguments, and offered to fill in the blanks for me. And it got all of those right. Those are the types that I want for those arguments. And delta time, what the heck is that thing? Same thing, annotate types. I was passed a float, and I returned nothing. So the debugger can be used for other purposes than debugging because it keeps track of information. It can collect that information and do the annotations for you. One important point, let's see, collect. I had to go into a preference and turn that on under build, execution, deployment, Python debugger. Here is something by default, it's not selected. Why is it not selected? Oh, mouse over. Because it slows the debugger down. So I'm going to speed the debugger back up, turn that feature off, run my code. This time as I munch and go and look for help, annotate types. Oh, it remembered it from a previous run. But if you don't have that feature turned on, you won't get the benefit of that. I will stop there. Got any questions for me?
I do this time around. First of all, something fun. Jaime Arias says, awesome. And that's
Yay!
all.
Woo!
And then Michal Baska asks, when will a test to remote process be available?
Don't know. I don't think ever. I don't know if we have. I think that attaching to a process involves some local to your machine IPC protocols that are not available over a network, but I will defer to your much smarter than me team.
I will check with the team about that. I'll also check with the team about this sub process, but
I'll go back to your first one and say my awesome game. Awesome.
Sounds good. All right. I'll go ask the team.
All right.
Yes.
Wouldn't it be great if I could do debugging and breakpoints and stuff in Django? Well, of course I can. It's Python, except it's got this templating language thing. And if I run under the debugger, if I run my Django signed under the debugger and go to the UI for it, and I go to some screen, blah, blah, blah. Well, I'd like to know a little bit more about what's happening here. There's this thing that if I configure some social account providers, it's going to say something. Well, what's the value of this? Didn't I get it set up correctly? I sure would like to debug this. Wouldn't it be great if I could set a breakpoint in a template instead of Python code? And wouldn't it be great if reloading that, oh, let's see, am I in the wrong place? Yep. I think I might be in the wrong spot for that. I've done something wrong on this. I had misconfigured this just before the project and got that wrong. So I'll skip it on Django. It's the same process under Flask, where I can run something under the debugger, go visit a page, and then I can, in my loop, if I want to see what is the value of task, I set a breakpoint there, reload it. What have I done? All right, I will admit this was working just before I did my demo. I don't know if it's because don't think it's because I'm running something over here. It's just, debugger is active. All right, I have made a mistake, so we'll have to go back to the other one, and if I can get this fixed and attach it to the recording, then I will do so. All right, next. And of course, someone might, Elizaveta might be watching this and knows exactly my stupid mistake. All right, I could talk a little bit about extra credit. Since we're already at the limit of time, I will show one that's pretty cool. Is we have a visual debugger. WebStorm, our JavaScript IDE, also has a visual debugger for JavaScript. Since PyCharm Professional includes WebStorm, can I debug JavaScript using the same visual UI using PyCharm? So I'm going to go and I'm going to do Node.js without a browser first. I'm going to open this file and I'll put it on this side. And I can run this using Node.js. I can also debug this, set a breakpoint right there, click debug, and Node.js is running instead of Python. And I've got this same UI with local variables and watch expressions and frames and the console and everything, except it's JavaScript. So I will continue, But what if I have actually a web application with HTML running in Chrome instead of a server-side Node.js application? We also have something called JavaScript debug configuration. So I've got an HTML page. If I debug this, it's going to fire up Chrome, and it's going to use a Chrome extension installed in Chrome to remote control Chrome from the IDE. So that, for example, if I go to this and put a breakpoint and then rerun my debugger, then Chrome stops execution, hands control back to PyCharm, which can step through the JavaScript code, inspect the values, all while moving the process of execution through the JavaScript interpreter in Chrome. I can continue stepping, I continue stepping, I can continue stepping, and there's my alert. All right, what else did we have under extra credit? Stepping can be configured. I can go into my preferences, go to stepping, and tell it for JavaScript, never go into these kind of files. In Python, never go into these kind of files, and add custom patterns and things to the list. All of the things that I'm doing with my mouse for debugging, I'll actually stop it here. Instead of stepping with my mouse, I can, let's see, oh, I ran it instead of debugged it. Instead of stepping with my mouse, I can step with my keyboard. And as I hover over these, I see the shortcuts for that. I can, as I get lost in my code, I can click a button that scrolls me back to my execution breakpoint. So for example, I'm down here, where am I actually stopped? I click that, it scrolls me back to that point. At some point, I might have so many breakpoints that I've gotten confused and I want to just run the thing. There's an option to mute all the breakpoints temporarily instead of having to go delete them. And if I'm sitting on a value and that value for whatever reason might have multiple lines to it, like some HTML or a long title, I can say inspect, pop up a new window, and see this in isolation. Okay, that brings me to the best 2 words of any webinar. In conclusion, do we have any final questions?
We do. Several people asked if you can use JavaScript debugging with Django.
Of course you can, because it's executing in a way that has no idea that Django is there. Now, if what you're saying is my JavaScript is defined in static assets that are configured in the Django side, yes, you can. You just have to do a little bit more work. I'm going to go to the run configuration definition for that JavaScript debug setting. And if your Django site is on a different computer, or if they are arranged in a URL hierarchy that might not be obvious from the PyCharm project, you can go in here and rearrange your hierarchy to find the original sources.
All right, thank you so much. Those are all the questions we had left.
All right. Okay, so in conclusion, this is about visual debugging. This is an attempt for beginners to get into Python debugging in a more friendly way with a nice, pretty UI, and for intermediate people to start picking up some features maybe they aren't using yet, like watches, and then to go over some things. We'll have to show you Django and Flask later, but to go over some extra credit things that you didn't know yet, for example, debugging in JavaScript, which can really help. We'll get the recording up later. If you have any questions, just ask either on Twitter or in the blog post. Ernst, I'll turn it over to you. Thank you everyone for attending, and thanks for using PyCharm.
Yeah, thank you so much. All right, so if you do have any questions later, please don't hesitate to reach out to us by email or social media. Thank you so much, Paul, for your presentation. We all learned a lot, I think. A lot of people were being very thankful in the questions pane. If you would like to get additional information, go to jetbrains.com/PyCharm. We would appreciate to get your feedback on this webinar, so please feel free to send us your feedback on Twitter or in the after webinar survey. This recording will be made available on our YouTube channel soon, and at that point we'll also announce it on our Twitter and on our blog. Our blog is at blog.jetbrains.com/PyCharm. If you haven't already, check it out. On our blog, you can find up-to-date PyCharm news about release and events, in addition to educational resources. So for example, the recording of this webinar will be published there. We'll also provide some additional links and information from Paul's presentation over there, including the GitHub link that everybody's been asking for. All right, thank you very much for joining us today. And we'd like to wish you to have a great day. Thanks and goodbye.